Okay, so today we're going to do ionic bonding. First, we need to know what ions are, so make sure you take a look at the video posted previous to this called ions. So today is ionic bonding. What we're going to do is make compounds that have metals and nonmetals together. So it's going to be one metal mixed with one nonmetal. First thing we're going to do is we're going to name the compounds. So naming them, what we do is we name the metal first, and then we name the nonmetal. The other thing special that we have to do is we have to change the ending of the nonmetal to IDE. So if I choose a non-metal like chlorine, what chlorine is going to change into is chloride. So CHLORINE is going to change into CHLORIDE, chloride. Another example would be if I took oxygen. So oxygen, OXYGEN, and that is going to change into oxide, OXIDE. So what we're doing is we're taking the last bit off and we're changing to IDE. So some more examples would be nitride, oxide, fluoride, phosphides, sulfide, chloride, arsenide, selenium, selenide, bromide, iodide, some things like that. Okay, so these are the nonmetals on this side of the periodic table. On this side of the periodic table is where you find all your metals. In the middle is the transition metals, and those are going to be our multivalent compounds, which will be the next video after this, ionic compounds. So we're really only going to use these two columns for metals, and then these elements over here for our nonmetals. So if we take the compound KF, we are going to name that. So K is potassium, and F is fluorine. So we put it together, it's going to be potassium fluoride. So again, K is potassium, F is fluorine, and we change the ending to fluoride. Another example. So if I have this, Ca3N2, so Ca is calcium, and then N is nitrogen. So we put them together, and it becomes calcium nitride. Again, changing nitrogen into nitride. One more example. We'll do Li. So we have Li2S. Again, Li is lithium, S is over here, and it's sulfur. So every single time I name these elements, it's always one metal and one nonmetal. So Li is lithium, and S is sulfur, so I change that to sulfide. Just like that. Okay. The next thing we're gonna do is I'm going to give you the name and you need to come up with the formula. This is where those ions come into hand, and it's very important to know the charges of those ions. So looking at this periodic table, the one that I gave you, these blue numbers here, so the 1 plus, 2 plus, 3 plus, 4 plus, 4 minus, 3 minus, 2 minus, 1 minus, those are all your charges. So we need to know that the columns there all have that charge. So if we try and name sodium, S-O-D-I-U-M, sodium oxide. So this is the name of it, sodium oxide, and what we're going to do is figure out what the formula is. So the compound like this. So sodium, on our periodic table, we find it over here, and it is Na. So I know that sodium is Na, and I know that oxide is oxygen, and oxygen is an O. We also, however, need to figure out what the charges are. So sodium has a charge of 1 plus, and oxygen has a charge of 2 minus. What we do with those charges is we write it up above. So 1 plus and 2 minus. What we're going to do next is drop those signs. So it's going to become Na1, O2, and then we're going to cross those charges and drop them down below. So the 2 goes over onto the Na, and the 1 goes over onto the O. So it becomes Na with a 2 down below, and an O with a 1 down below. So most times you won't see this 1 written. It's not really that important. You won't be marked wrong if you write it there, but it's just, so most times you won't see it there. So if there's nothing there, it's an assumed 1. So sodium oxide, the compound formula is Na2O. We'll do another example. If I do barium, barium phosphide. Okay, so again, we need to know what barium is. Barium is here, and it's Ba. We need to know what phosphide is. Phosphide is phosphorus, which is a P. So we have a Ba, and we have a P. The charge on barium is 2 plus. The charge on phosphide is 3 minus. So barium is 2 plus, phosphide is 3 minus. Again, we're going to drop those signs, so the plus and minus. We're then going to cross the numbers and drop them down below. So then it will become Ba3 and then P2. So make sure you're writing those numbers as subscripts. They need to be down below. That is where they need to be. Okay, and we're crossing them. So the P has the 3. That means the opposite one, Ba, would have the 3. The Ba had the 2. It's going to cross over and go on the P. So the P has the 2. We will do one more example. So we'll do potassium bromide. Actually, I don't like that one. Let's do magnesium. Magnesium selenide. I think I spelled that right. So magnesium is Mg, and selenide is selenium, which is Se. So we get Mg, Se. Mg has a charge of 2. Se also has a charge of 2, but one is 2 plus, and the other one is 2 minus. We're still going to drop the signs and crisscross the charges. So Mg, the 2 goes over here. Se, 2 goes over there. What is special about this compound, though, is that they have the same amount of charge. We can reduce these. A ratio of 2 to 2 is the same thing as 1 to 1. So 2 to 2 is the same thing as a ratio of 1 to 1. So my new compound becomes Mg, Se. And remember, if there's nothing written there, those are silent ones. So there is Mg1, Se1. And that's how you name magnesium selenide.